Hello, welcome to the webinar on how to improve the price performance of Amazon RDS and Amazon Aurora with AWS Graviton2 instances. My name is Sundar Raghavan and I'm a senior database specialist solutions architect, and I've been with AWS for about 3.5 years now. We know that customers are constantly looking for ways to make their database workloads more efficient in terms of performance and cost. In this tech talk, I will provide you an introduction to our Graviton2 instances and available instance types for RDS and Aurora. So here's the agenda. Let's start with what Amazon RDS is and some background. I will then talk about the options customers have when it comes to the choice of processes for relational database workloads in the cloud. And then move into Amazon Aurora and Amazon RDS instances powered by AWS Graviton2 processor. I will also touch upon how it improves the price performance of Amazon RDS and Aurora. Then share some sample workload where Graviton would shine. We'll conclude the session with some frequently asked questions and later open up for question and answer. So, what is RDS? Since the beginning of Amazon.com, we have run some of the world's largest and busiest production relational databases. So we understand how expensive and complex it can be to manage database administrative functions, including regular patching cycles, performance optimization, and backup and recovery for constantly changing applications. Adapting these operations to the cloud also requires new skills and training. For customers running legacy data infrastructure on-premise, provisioning, operating, scaling, and managing databases is tedious, time-consuming, and expensive. Customers want to spend time innovating and building new applications and not managing infrastructure. Amazon Relational Database was built by AWS as a way to help customers reduce the complexity in supporting critical transactional applications by making it easy to set up, operate, and scale a relational database in the cloud. RDS automates time-consuming administration tasks such as hardware provisioning, database setup, patching, and backup, while providing cost-efficient and resizable capacity. It frees you to focus on your application so you can give them the fast performance, high availability, security, compatibility they need. RDS is available on several database instance types, optimized for memory, performance, or I/O, and provide you with 6 familiar database engines to choose from. Amazon Aurora, compatible with MySQL and Postgres, MySQL, Postgres, MariaDB, SQL Server, and Oracle. With Amazon RDS, customers are able to spend time innovating and optimizing their application's performance and capabilities instead of operational headaches. With Amazon RDS backup, snapshot scaling, both storage and compute, high availability and upgrades are all handled with a few simple clicks. The most straightforward and simple solution for many customers who are struggling to maintain their own open source database at scale is a move to a managed database service like Amazon RDS or Amazon Aurora. In most cases, these customers can migrate workload and applications to a managed service without needing to re-architect their application, and their teams can continue to leverage the same database skill sets. The target customers for a move from a self-managed to a managed open source database is self-managing open source database on-premise or on EC2 or in other public cloud. Those who would like to reduce the database administration burden and relocate DBA resources to the app-centric world so that they can focus more on application development, adding new features to their business. Who does not want to re-architect their application, want to continue leverage the same skill set. Just need a simple path to manage services in the cloud for open source database workload. Database administrators are under tremendous pressure every day to deliver value to the business across a variety of fronts. In general, a business goals for using the data it gathers are to better understand the business, reduce cost, increase revenue, and deliver improvement and result. If you are spending most of your time each day installing software, preparing systems, or any number of redundant tasks, that leaves less time to work toward actual business goal. The more time you spend in moving the business forward, the more likely that you will become a recognizable force of progress. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your application so you can give them the fast performance, high availability, security, and compatibility that they need. Because of its ease of use, high availability, and cost effectiveness, Amazon RDS has hundreds and thousands of customers today. Some of the big name brand names are shown here in the slide. So before we talk about how can you take advantage of the Amazon or AWS Graviton2 processors, let's talk about the processors themselves. Amazon EC2 also has a broadest choice of processors, including a full range of Intel Xeon processor. We also leverage the EPYC processors from AMD, powerful but cost-effective options for x86-based workloads. Finally, we have our own custom design and built silicon, the AWS Graviton family of processors. Let's dive a bit deeper into Graviton. AWS Graviton processors are custom AWS silicon designed by Annapurna Labs with 64-bit ARM Neoverse N1 cores. With our vast experience in running cloud-native workloads at scale, we have been able to target specific optimization in the chip itself. Graviton is literally designed for the cloud. By building our custom processors, we can rapidly innovate and iterate on behalf of customers, providing a great performance with significant cost saving. So how can you take advantage of AWS Graviton 2? As I mentioned before, AWS Graviton processors are custom built by Amazon Web Services using 64-bit ARM Neoverse cores to deliver the best price performance for your cloud workload. The first generation of AWS Graviton processors power Amazon EC2 A1 instances, the first ever ARM-based instances on AWS. AWS Graviton 2 processors deliver a major leap in performance and capabilities over the first generation AWS Graviton processor. So when it comes to the database workload, to make use of the AWS Graviton 2, AWS Graviton 2 based database instances are now generally available for Amazon Aurora with Postgres compatibility and Amazon Aurora with MySQL compatibility. AWS Graviton 2 instances are also generally available for Amazon RDS for MySQL, Amazon RDS for PostgreSQL, and Amazon RDS for MariaDB. AWS Graviton 2 instances provide up to 35% performance improvement and up to 52% price performance improvement for RDS open source databases, depending on database engine, version, and workload. High performance networking and storage, next generation elastic network adapter, and NVM Express technology provide M6G instance with the high throughput, low latency interfaces for networking and Amazon Elastic Block Storage, EBS. Built on AWS Nitro systems, which are rich collection of building blocks that offloads many of the traditional visualization functions to dedicated hardware and software to deliver high performance, high availability, and high security, while also reducing visualization overhead. Amazon Graviton2 processor is a custom AWS designed and purpose-built processor that has been fabricated on the 7 nanometer processor. The processor is based on 64-bit ARM Neoverse cores. With 30 billion transistors, the Graviton2 CPUs are gives 7 times performance, 4 times the number of compute cores, 2 times the large private caches per core, and 5 times the faster memory over the first generation AWS Graviton processors. Additionally, AWS Graviton2 processors feature always on fully encrypted DDR memory and 50% faster per core encryption performance. These performance improvements make Graviton2 R6G database instance a great choice for database workload. You can launch Graviton2 R6G database instances in the Amazon RDS management console or using AWS CLI. Upgrading a database instance to Graviton2 requires a simple instance type modification. Using the same steps as any other instance modification, your application will continue to work as normal and you will not have to port your application code. From the application perspective, your application will continue to work normal. As far as the version supported, Graviton2 is supported by Aurora MySQL version 2.09.1 and higher, and Amazon Aurora Postgres version 11.9 and higher, and on Amazon RDS for MySQL version 8.0.17 and higher, RDS for Postgres version 12.3 and higher, and Amazon RDS for MariaDB version 10.4.13 and higher. Here we have some sample instances that you can use. Amazon RDS instances are available in multiple configurations, starting with 2 vCPUs with 8 gig memory for M6G and 16 gig of RAM for R6G, up to 10 gigabits of network bandwidth, giving you new entry-level general purpose and memory optimized instances. First, let's talk about the R5 instance and walk you through some details about the AWS Graviton2 powered Amazon RDS and Aurora instances. When you get to the large classes like the R516XL and the R524XL, they have 2 sockets. And you have a bunch of vCPUs in each of those sockets and then local memory. Also, if you are reading from one of the sockets from one of the vCPUs and you're looking at its local memory, that's called local access. But if you have to cross to the other socket's memory, it's called remote access. This is what we call as a non-uniform memory access, or NUMA. This causes a bit of slowdown. When you start getting into these multi-socket systems, that's not a lot, but it does add a bit of delay and can cause a little bit of top-end scaling loss. Conversely, with our Graviton2 instance, R6G, this is a non-issue because we only have a single socket. Here, I'm showing the 16 extra large of the R6G, so it has 64 vCPU and its memory is local. Now, this is an oversimplification, just like the previous slide, in that like it's matrix of memory model, and there's a lot of other complexity with the CPU. But from your perspective, the main takeaway is that it is local, it is uniform. So you won't see this change as you go from like an 8XL to a 16XL. You're going to see a very linear performance characteristics. The other major difference is that on a R5, when you have two vCPUs, one of them is going to be an SMT or hyper-threaded CPU. So when we add work to a CPU, in this case, I'm showing a bit of work showing up in a CPU and one and CPU two. It's going to have to go and be processed, and there is some shared execution resource. As you can see, the two different colored processing capacities are moving into the execution resource in queue. So if it's like this example where there's a bit of time between them, it's going to look like you are getting two full CPUs, but you don't really see any difference, because even though it's time sharing, it's not going to make a difference. But if you get into four coming in, then what happens is those shared resources are busy and can execute, and so it takes longer. And as you add more and more vCPU in the higher end, then you might see this delay. So it looks like it's running slower. You get lesser throughput. Conversely, on our R6G with Graviton2, we have two full vCPUs. So when that work comes in, they both go to full CPU and they get done sooner. Why do you care about this? Let's look at the performance that we did internally. So here, to illustrate a sort of heavy CPU application, we have built 1,000-row range scan with a 3-level nested loop to a couple of other tables that also has about 1,000 rows. The vertical axis is the queries per second, so higher the number of queries is better. And in the blue, we have this R6G, and in the purple is R5. And these are largest, so basically two vCPUs, and the connections on the bottom are sessions. So at one connection on the x-axis, both of these are one vCPU, which are burning full. And so they are like regular, since they are regular CPUs, so you will see the performance on par to each other. But as soon as we start moving into the higher load, as soon as we start adding more load, move to 2, we can see that it's a dramatic difference. The hyper-threaded CPU only picks up about 30% improvement, but the Graviton2 CPU basically doubles. And so we see 70% difference between these two large instances based on the full CPU as opposed to the hyper-threaded one. So this is a very similar scenario with the load testing and benchmarking software, but instead we use the HammerDB, because in the real world, it's not likely to have a workload that is going to be purely read heavy. So it's going to be sort of mixed workload. So how does it work? How does it look on an application that is not completely CPU bound? And this is how it's going. So we are going to talk about that. So we took the HammerDB, which does the I/O as well, along with the read, and we ran this test. So on the vertical axis is a new orders per minute. And so again, higher the order is better. And then this time we are using the extra large, which has 4 vCPUs. The blue is still the R6 and the purple is R5. And what we see is that as we get towards the top end, we see about a 15% performance improvement for the Graviton2 over the R5. And this is because we still are seeing some of the CPU benefits, even though there are other things that is going to be contained, something like related to the I/O and the temporary usage and etc. Given that the R6 is also cheaper than the R5, so even if it is just 15%, it is 15% plus the price difference. So your price performance is probably going to be quite a bit higher. So on the R6, on the large instance like what we have here, I'm showing the 16XL as well as a 24 on the same benchmark. So again, what we are going to see is that 32 vCPUs, these are very similar because they are on a full CPU. But as we move off and go higher and higher on the load, we are talking about using hyperthreading on the R5. We see that 16XL for the R6G being 50% faster because of actually gets a full gain. Now, the interesting thing is that we notice that the R6 still outperforms the R5 24 XL, 24 large, even though it is got more vCPU. And this is because it has come to content for both the hyperthreading and the NUMA, which means that it doesn't double over its 16XL in the same way. So if you don't need an extra memory and you can work with that, then you get the say we get with a 24XL. The R6G16 is really a better choice compared to the R5's 24XL. So this shows that the Graviton2 is a great for these this kind of CPU high and CPU heavy workload. So we repeated the similar kind of a test with Amazon RDS, this time on the RDS for MySQL on Graviton with Graviton2 processor. So what we found was, based on our internal testing, we saw that it can provide up to 35% performance improvement and up to 52% price performance improvement. And we use the RDS open source, so that you can use the Postgres or MySQL. It's all internal testing based on the open source database. So here we compare the performance based on the orders per minute. As orders ramp up, you can see how we consume more threads and how effective Graviton2 is at higher thread counts. Running a write-intensive workload on RDS MySQL, you will see that the difference is, so the more the read heavy or the more the CPU heavy it is, it's going to be beneficial for you. And again, these are all internal benchmarks, so we highly encourage you to test your own workload to come to a conclusion and pick the right instance choice. Okay, so now we'll talk about the key database workloads for Graviton2 processors. These are some of the sample workloads. Essentially, any workload that is heavy on CPU is going to perform better. The more towards the CPU load it is, then you're going to see the better performance, and also the price performance efficiency is going to go up. For example, any moderate analytical workload that is heavy on CPU, if a workload that you constantly do the encryption and decryption outside the KMS and then you still do it on the database, and some image and map processing, for example, and with Postgres, PostJS, or PG routing, etc. Some workloads that are heavy on JSON and JSON-B, or sometimes the native database, native parallel query options that comes with Postgres and MySQL. So these are some sample workload, and then again, we encourage you to test it and then identify the right workload, and then you can get the benefit. So now, how can you move to Graviton? So how can you take advantage of AWS Graviton2? So you can create an instance, and then when you create the instance, so if it is an RDS instance, then you can pick the M5Gs and R5Gs instance types, and then you can create it. Or if you want to modify an instance, you can also go through the same process, modify the instance type, and then choose the right instance type, and you can apply it. And that's one option. So when it comes to the Aurora, it's the same process. You can add, in fact, let's go through how a bit of process how you can use this. So first, you can modify one of the reader to an R6G, and then run the test. And then if your application performance comes out to be good, then you can convert the rest of the instances. You can fail over to the R6 instance, and then you can convert the rest of the instances and then move to the R6G. Similarly, if you want to modify an existing instance, you can pick an instance and modify it, and then choose the instance type that you want, and you can apply it. Again, if you want to test it out, then you can have additional reader added to the RDS instance, and then add it as a Graviton2 based instance, then test it out, and then you can do the failover and then slowly convert it one at a time. So now I'm going to show you how to add a read replica in this RDS instance, and I'm going to add a Graviton based reader instance for this one. So I click this RDS instance, and then I'll choose from here, action, create a read replica, and give the instance name. Here, I can choose the instance type I want to choose. So I can pick the same instance or a different one, so I'm going to go with the same. So I can also choose a different region where if the region is supported, and then based on that, I can do this. So I'll just pick the name as RPG dash. And that these two are processing and it's adding the instance. So while this is running, I'll wait for this. Once it's added, then I'll show you the outcome there. All right, so the demo I just created two Graviton-based Aurora reader and then RDS read replica, and both are completed. So here's the reader for the Aurora instance, and it's a regular instance that it's available and it's readily available, and it could be used. And you can also fail it over to the this instance and then make it as a writer if you want to use it. Similarly, for the RDS instance, I have a read replica which is also created, and then here is R64G, R6G 4x large, and here is R6G 4x large as well. So with that, the demo is, I'm concluding this demo. Let's look into the next section. So with that, we are coming to the frequently asked question session. So these are the questions that we came across oftentimes from a customer. So we want to address them. So some of the common questions that we came across are, do I need to recompile the application? No, the answer is no, you don't have to recompile the application because you're just changing one of the instance types. So you'll be connecting to the database and then you can start using it. Instance Amazon RDS instance powered by Graviton2, and applies to the Aurora as well. How do I move to instance that is Graviton2 based from an Intel based instance? It is similar to modify, like I mentioned. You modify the instance operation. You just go to the instance modify operation and then change the instance type, and that will switch from one instance type to the other one, and then that's how you migrate it. How can I get started with Amazon RDS instance? We recommend by starting with a new instance, adding as a reader in the case of Aurora, or if it is RDS instance, I can adding as a read replica and then testing it out. And then once you're comfortable with the performance, and you can slowly migrate and move it to the other side, and then slowly move it to the production. The other option is that obviously you can take a snapshot and then of the existing database and restoring it as a new instance with the Graviton-based instance and performance testing it, and then going live with that later at the production schedule time. The other interesting question that comes quite often is mixing of Graviton versus non-Graviton instances. Yes, you can combine them together. So you can have a Aurora writer as a x86 Intel-based system, Intel-based instance, and then you can have a reader that is Graviton2 based. And that way you can test out, and then you can, if you have analytical or CPU sensitive queries, then you can move them to the reader node and you can perform it. Or if you're just testing it for the purpose of migrating it, then you can move them and then test it out. And then once it's successful, like I shared the PowerPoint, the slide, you can swap it and then make them as a writer instance. Once you move to the Graviton, you can also go back to the x86 because again, you are modifying the instance type. So this might incur the downtime. So that's the only thing, but you can still do that. How much of downtime should a customer expect for modifying? There's a minimal downtime when you are scaling up your multi-AZ environment. So we recommend that you do it in an RDS world. You can do that in a multi-AZ environment. And in the case of Aurora, if you have a reader instance, then moving the writer to the reader, and similarly moving in a multi-AZ environment, moving the instance to the other side, that will minimize the downtime as well. So in order to use the AWS Graviton2 powered RDS and Aurora systems, the following are the versions that needs to be used with RDS and Aurora. So we support RDS, Amazon RDS for MySQL versions 8.0.17, 8.0.19 and 8.0.20, and Amazon RDS for Postgres version 12.3 and 12.4. Amazon RDS for MariaDB versions 10.4.13 and higher. As far as Aurora is concerned, Amazon Aurora MySQL version 2.0.09.2 and higher supports the db.r6g instance class. Amazon Aurora Postgres version 12.4 and higher and version 11.9 and higher are supported for the db.r6g instance class. So that's all that we have for the webinar today. So I'm going to open this up for general question and answers. So thank you very much.